So now that we've taken a look at pure series and pure parallel circuits in the previous two videos, let's now take a look at possibly the simplest combination of those, which is a series type hybrid, where you have one resistor that is in series with a pair of resistors that are in parallel with each other. So let's see how we can calculate the current through, voltage drop, and power dissipated by each resistor in this circuit. So, as usual, good practice, well, you've got to find the equivalent resistance of the whole thing in order to figure out what kind of current's coming out of the battery. So, we're going to list our givens, and we're going to keep in mind what's actually going on here. We have a 30 ohm resistor that is in series with this stuff that we're just going to call, well, stuff. How do we know it's in series? Well, let's again follow the current as it comes out of the battery. The current comes out, and remember the long end of the battery is the positive terminal. So current comes out of here, and it first goes through the 30 ohm resistor, and then it goes through stuff. And then it comes back to the negative terminal or ground or zero, however you want to think of it. So the equivalent resistance of the circuit, well, it's going to be given in a way by the series formula, because the 30 ohm resistor is in series with stuff. Well, that's just going to be the resistance of the 30 ohm resistor, which we're calling R1, plus the resistance of stuff. So in order to proceed, we need to figure out the equivalent resistance of stuff. So let's see how we're going to do that. Well, we need to calculate that, but stuff is a parallel element. In other words, when the current gets to stuff, inside of stuff, the current either goes through the 10 ohm or it goes through the 15 ohm. Remember that either or is a signal that this is a parallel element. So to figure that equivalent resistance out, you got to figure out the equivalent resistance. You got to do 1 over the resistance of stuff is equal to 1 over the 10 ohm resistor, which we're calling R2, plus 1 over the 15 ohm resistor, which we're calling R3. Well, let's plug them in. So a common denominator between 10 and 15 turns out to be 30. There isn't a smaller one than that. The least common denominator is 30. You know that there is a common denominator of 30 because hopefully you've watched the pure parallel video where we had a 30 and a 10 and a 15 in parallel, and I mean that gave a common denominator of 30. So certainly a 10 and a 15 in parallel will give a common denominator of 30, and there is no smaller one. So we turn all of these denominators into 30. So to do that with the first one, we need to multiply top and bottom by 3. Why do we multiply the top by 3? Well, we've got to keep it as still the same thing as 1 over 10. Well, 3 over 30 is the same thing as 1 over 10, so multiply top and bottom by 3. And multiply top and bottom of the 1 over 15 by 2 to get 2 over 30. Well, 3 plus 2 is 5. So if 1 over the resistance of stuff is 5 over 30 ohms, that means that the resistance of stuff, or resistance of stuff over 1 if you prefer, is equal to 30 ohms over 5, and that's 6 ohms. So the equivalent resistance of stuff is 6 ohms. Well, remember that stuff is in series with the 30 ohm resistor, so the equivalent resistance of the whole circuit is given by 30 ohms plus the resistance of stuff, because it's in series, equals 36 ohms. So now that we know the equivalent resistance of the whole circuit, we can next figure out the current that comes out of the battery using Ohm's law. So V equals IR, so I equals V over R. Well, V for the battery is 27.5 volts. We listed that in our givens before. Divide by the equivalent resistance of the whole circuit. That gives us about 0.764 amps coming out of the battery. So that battery, remember, look at this circuit, notice this battery is in series with the 30 ohm resistor. So that means that whatever current comes out of the battery is also going through the 30 ohm resistor. So we can immediately make that statement. That's a boxed answer. That's one of the things we're looking for. Find the current and voltage drop and power dissipated by each resistor in the circuit. Well, we just found one. And you can immediately calculate the voltage drop across that resistor using V equals IR. So plug in that current that goes through that resistor, multiply by the resistance of that resistor. Again, we called that resistor 1, and you get about 22.92 volts. In fact, you get exactly 22.92 volts. Now, to figure out the current in each individual one of these two resistors, it's actually good first to know what the voltage drop across these is. And we can figure that out right now because we know that the total amount of current that's going through stuff is 0.764 amps. How do we know that? Because stuff is in series with our battery and there's 0.764 amps coming out of the battery. So we know that a total of 0.764 amps is going through stuff. We just don't know how it's distributed. But I know the resistance of stuff. The resistance of stuff is 6 ohms. That's the equivalent resistance of a 10 ohm and a 15 ohm in parallel. So, since I know that, I can use V equals IR to figure out the voltage drop across stuff. Again, I don't know the current through the individual resistors, but I know the total current is 0.764 amps through stuff, and I know that the equivalent resistance of stuff is 6 ohms. So I multiply those together, and I get that the voltage drop across stuff is 4.58333333 volts. But look, remember, stuff is composed of, it's an element that is composed of two resistors in parallel. And remember that for parallel elements, the voltage drop across the whole thing is equal to the voltage drop across each arm in the parallel element. So, if the voltage drop of stuff is about 4.58 volts, that means that the voltage drop across the 10 ohm and the 15 ohm resistors are also each 4.58 volts. So, that's something that we got immediately by figuring out the voltage drop across stuff. And those were two of the things we were asked to find. Find voltage drop and current and power through each resistor. Well, we found the voltage drop across each of these resistors just now. Now we can turn our attention to calculating the current through each resistor using, surprise, surprise, Ohm's law. Well, just a reminder, here were our givens and things that we have just found. So V equals IR, so I equals V over R. So I'm going to do that for each of those two resistors. So remember the 10 ohm resistor was resistor 2. So we have the voltage drop across that divided by the resistance of resistor 2 is going to give you the current through resistor 2. In other words, the current through the 10 ohm resistor. That turns out to be 0.458 amps. Now, there are two ways now of figuring out the current through the 15 ohm resistor. Since the 15 ohm resistor is the only resistor left in the parallel circuit of stuff, you could just subtract this 0.458 amps off of our previous total current that we had calculated from before of 0.764 amps. But let's just do it the standard way, the same way that we figured out the current through resistor 2. Well, again, it's just the voltage drop for the current through resistor 3 is the voltage drop through resistor 3 divided by its resistance. Well, that's 4.58 volts divided by 15 ohms. And notice, by the way, I kept the true numbers from the calculator in my calculation. In fact, I actually plugged in 4.58333333 volts and divided by 15 divided by 15 ohms to get about 0.306 amps. And indeed, no surprise, when you add these things together, you get 0.764 amps, which is, if you go back over here, the total current that went into stuff. So we just calculated how it broke up and thus got the final currents that we needed to find. So now, figuring out the powers is very easy. You just use PIV 3 times, once for each resistor. So we'll just do that real quickly, and you get a power of 17.5 watts in the first resistor, the 30 ohm one, and a power of 2.10 watts through what we call the second resistor, the 10 ohm one, and a power of 1.4 watts through the third resistor, the 15 ohm one. And that, if you want, you could use that and add them up to get the total power dissipated by the whole circuit, which is 21 watts if you're interested in the power consumption of the whole circuit. So that's how you can figure out the equivalent resistance, the voltage drop, and the current through each resistor in a simple hybrid circuit. So this was a situation in which the hybrid is a series type. In other words, first the current goes through one part of the circuit and then the current goes through the other part of the circuit. It's also useful to look at a situation in which the current splits off immediately out of the battery and goes into two different elements of the circuit, in which the two different elements are not just one resistor each, but might be two resistors each. So next we're going to look at a parallel type hybrid in the next video. Thank you.